हेलो एवरीवन, दिस इज निहाल एंड हम सॉल्व करेंगे बिहार पीसीएस 2019 64th बिहार पीसीएस 2019 पेपर वन का सॉल्यूशन. एंड लेट अस डिस्कस द सॉल्यूशन ऑफ फर्स्ट ए क्वेश्चन. It says that state Cayley-Hamilton theorem and using it find the inverse of the matrix. This type of question are asked in UPSC, UPPCS and VRPCS repeatedly. So Cayley-Hamilton theorem का statement पूछा है. Cayley-Hamilton theorem. It says that every square matrix, every square matrix satisfies its characteristic equation. Satisfies its characteristic equation. So what does this characteristic equation mean? We can find if a matrix A is given, then characteristic equation is A minus lambda I ka determinant is equal to 0. From here we can find characteristic equation of a matrix. So in the form of lambda, powers of lambda. So given matrix, now we need to find the inverse of a given matrix using characteristic equation. So given matrix A is 1 minus 1 1 2 1 1 1 2 3. So its characteristic equation A minus lambda I is equal to 0. That is 1 minus lambda minus 1 1 2 1 minus lambda 1 1 2 3 minus lambda ka determinant is equal to 0. So now we can find the determinant of this matrix, and equating it equal to 0 we can find a characteristic equation. But this method is prone to error, calculation error. So I will suggest a short direct method to find a characteristic equation. So let us discuss that. Lambda, it is lambda to the power 3, it is 3 by 3 order, minus trace of this matrix. Trace of this matrix is 1 plus 1 plus 3, that is 5 lambda square, plus summation of principal minus of this matrix. So first principal minor is this one. This is 3 minus 2 is equal to 1, and the second principal minor is of this matrix 1 minus 1 1 2 1 1 1 2 3. So second principal minus can be find by hiding these elements. So 3 minus 2 minus 1, it is 2, plus the third principal minor is this is 1 plus 2, that is 3 into lambda, minus determinant of this matrix. Determinant of this matrix is 9, so it is equal to 0. So lambda cube minus 5 lambda square plus 6 lambda minus 9 is equal to 0. This is characteristic equation of this given matrix. Now Cayley-Hamilton theorem says that every square matrix satisfies its characteristic equation. That means a cube minus 5a square plus 6a minus 9i is equal to 0. We multiply both sides by a inverse. That means a square minus 5a plus 6i minus 9a inverse is equal to 0. That means a inverse is equal to 1 by 9 a square minus 5a plus 6i is equal to uh, is. So a inverse is equal to 1 by 9. A inverse is a square. A square is we can find a square by multiply a with a, which is equal to 0 0 3 5 1 6 8 7 12 minus 5 5a is equal to 5 minus 5, 5, 10, 5, 5, 5, 10, and 15 plus 6i is equal to 6, 0, 0, 0, 6, 0, and 0, 0, 6. By adding all these three metrics, we get 1 by 9, 1, 5, minus 2, minus 5, 2, 1, 3, minus 3, 3, which is A inverse. This is the answer of the asked question. Now let us solve 1B of 64th Bihar PCS paper 1 question. It says that T from V4 to V3 is a linear transformation. Now it gives that T of E1. E1 means in V4 E1 is equal to 1, comma 0, comma 0, comma 0, and E2. These are basis of this is a E1, E2, E3, E4 form the basis of V4. So 0, 1, 0, 0, E3 is equal to 0, 0, 1, 0, and E4 is equal to 0, 0, 0, 1. It doesn't matter what is E1, E2, E3, E4. Without knowing that, we can solve the question. Need to remember that E1, E2, E3, E4 are the part of basis of the V4. That's it. So E1 is equal to 1, comma 1, comma 1. T of E2 is equal to 1, comma minus 1, comma 1. T of E3 is equal to 1, comma 0, comma 0, and T of E4 is equal to 1, comma 0, comma 1. So we need to find the rank and nullity of linear transformation T. So to find rank, what we do is we find the image of basis elements, and then we choose those elements which are linearly independent out of them. So whichever is linearly independent out of these four will form the basis of range space, and dimension of that is rank. Rank is equal to dimension of range space. So how to find the basis of range space is the image of basis elements of the domain form the range space, and out of these we select those vectors which are linearly independent. So out of these four we need to determine which are linearly independent. For that, let A be matrix formed by these vectors as row vectors: 1, 1, 1, 1 minus 1, 1, 1, 0, 0, and 1, 0, 1. So now we reduce it to row reduced echelon forms. So apply R2 to these are row operations: R2 to R2 minus R1, R3 to R3 minus R1, and R4 to R4 minus R1. This gives us 1, 1, 1, 0, minus 2, 0, 0, minus 1, minus 1, 0, minus 1, 0. Now let us apply row operations R4, R4 minus R3, and R2 R2 divided by 2. This gives us 1, 1, 1, 0, minus 1, 0, 0, minus 1, minus 1, 0, 0, 1. Now let us apply row operations R3 to R3 minus R2. So this gives us 1, 1, 1, 0, minus 1, 0, 0, 0, minus 1, and 0, 0, 1. Now let us apply row operation R4 to R4 plus R3. This gives us 1, comma 1, comma 1, 0, minus 1, 0, 0, 0, minus 1, and 0, 0, 0. So this is row reduced echelon form, sir. It has three non-zero rows. That means dimension of range space is 3. Now by rank nullity theorem, that means rank is 3. Rank rank nullity theorem says that if T be a linear transformation from finite dimensional space V to U, then this V has to be finite dimensional, then dimension of V is equal to rank plus nullity. So in this given question we have dimension of V is equal to 4. So 4 is equal to rank plus nullity. Here rank is equal to 3. That means nullity is equal to 4 minus 3 is equal to 1. So rank is 3 and nullity is 1. Thank you guys. This is the answer and you can join Telegram for the further Telegram group for the